Hi, Dave Kilgore back with you, getting ready for study session number 17. So, in this session, we're going to go over the general electrical requirements, definitions, services and branch circuits, and feeder requirements based out of the 2021 IRC Chapters 34, 35, 36, and 37. After we go through our study session, at the end of the study session, we'll have a list of 35 questions that you will want to have your 2021 IRC open to these chapters. I'll ask the question. You'll pause the video at that time, look up the answer, and then come back to verify your answer. Our objective today is going to be to obtain an understanding of the general requirements for electrical systems, equipment, and components, including provisions addressing service conductors, branch circuits, and feeders. As I said, our reference today is going to be the 2021 International Residential Code, chapters 34, 35, 36, and 37. Our key points that we're going to go over today: what minimum working clearances are required at energized equipment and panel boards? How is clearance above a panel board regulated? And what is the minimum required headroom? What materials are permitted for use as conductors? What is the minimum permitted size? And how are stranded conductors regulated? How about conductors in parallel? Or how are the conductors to be identified? What is the difference between accessible and readily accessible? And how do dry, damp, and wet locations differ? As well as how is rainproof different from rain tight? What are the requirements for labeled and listed equipment of materials? And how do these terms relate to that of identified? Where must the service disconnecting means be located? And what is the maximum number of disconnects? How is the minimum load for ungrounded service conductors to be calculated? What minimum clearances are mandated for overhead service conductors from doors, porches, decks, stairs, and balconies, above roofs, above pedestrian areas and sidewalks, over residential property and driveways, over public streets and alleys or parking areas subject to truck traffic? How are connections at service heads to be installed? What is the basic method for creating a grounding electrode system? And when is the use of a metal underground water pipe permitted for such a system? How about a concrete encased electrode, ground rings, or plate electrodes? What is a made electrode? And when are such electrodes permitted? What minimum sizes are required for rod and pipe electrodes? How are they to be installed? What is the minimum required resistance to ground? And how may this be achieved? Where is bonding required to ensure electrical continuity? And what methods of bonding are permitted? What are the rating requirements for branch circuits serving lighting units and general utilization equipment, fixed utilization equipment, motors, ranges and cooking appliances, heating loads, air conditioning, and heat pumps? How many branch circuits are required to serve the kitchen and dining area? How about the laundry area or the bathrooms? How is the size of feeders to be determined? How about the conductor sizing? All right, we're going to start off with drilling, notching, and penetrations. Building structure protection, IRC Section E 3402. Wood frame structural members shall not be drilled, notched, or altered in any manner except as provided for in the IRC. Electrical installations in hollow spaces, vertical shafts, and ventilation or air handling ducts shall be made so that the possible spread of fire or products of combustion will not be substantially increased. Electrical penetrations into or through fire resistance rated walls, partitions, floors, or ceilings shall be protected by approved methods to maintain the fire resistance rating of the element penetrated. Penetrations through fire blocking and draft stopping shall be protected in an approved manner to maintain the integrity of the element penetrated. Through penetrations and membrane penetrations of fire resistive elements must be protected in accordance with the requirements of Section R302.4, where fire blocking and draft stopping is mandated by Section R302.11 and Section R302.12, respectively. The penetration by electrical installations must also be done in an appropriate manner. For the notching and boring of structural wood framing members, Section R502.8, 602.6, and 802.7 must be followed. These requirements are in addition to those mandated in Table E3802.1 for the protection of the electrical cables and conductors installed in such framing. Working clearances. Sections are IRC E3405.2, equipment location and clearances. Except as otherwise specified in chapters 34 through 43, the dimension of the working space in the direction of access to panel boards and live parts of other equipment likely to require examination, adjustment, servicing, or maintaining while energized shall be not less than 36 inches in depth. In addition to the 36-inch dimension, the workspace shall not be less than 30 inches wide in front of the electrical equipment and not less than the width of such equipment. The workspace shall be clear and shall extend from the floor or platform to a height of 6.5 feet or the height of the equipment, whichever is greater. So a minimum depth of 3 feet in front of the access point to an electrical panel board is needed to allow for adequate clearance for a person from any live parts. It provides enough working depth to both maintain a safe distance and allow free movement when a person is servicing or maintaining the equipment. As you can see here, it's got 36 inches in front of the panel and 30 inches wide. So regardless of the size of the panel board, a minimum clear width of 30 inches is required for working space. It need not be centered in front of the equipment, but should be located for safe access. If the panel board exceeds 30 inches in width, the clear space minimum to extend to full width. Section E3405.3, equipment locations and clearances. The indoor space equal to the width and depth of the panel board and extending from the floor to a height of 6 feet above the panel board or to the structural ceiling, whichever is lower, shall be dedicated to the electrical installation. Piping, ducts, leak protection apparatus, and other equipment foreign to the electrical installation shall not be installed in such dedicated space. In addition to the working space that must extend vertically in front of the panel board, the area directly above the panel board itself is regulated. This area must be free of any equipment or building features that would interfere with the direct run of cables and or conduits to the equipment. The only exception allows for a suspended ceiling to encroach into the dedicated panel board space, provided it has ceiling panels that are removable. Similar requirements also apply to panel boards located outdoors. This provision reserves the area above the panel board for the exclusive use of electrical system and its components. Plumbing and HVAC piping, ducts, and equipment must be located outside the designated area. Splices. Section 3406.11.3, conductors and connections. Where conductors are to be spliced, terminated, or connected to fixtures or devices, a minimum length of 6 inches of free conductor shall be provided at each outlet, junction, or switch point. The required length shall be measured from the point in the box where the conductor emerges from its raceway or cable sheath. Where the opening to an outlet, junction, or switch point is less than 8 inches in any dimension, each conductor shall be long enough to extend at least 3 inches outside of such opening. So to provide adequate conductor length for connection purposes, at least 6 inches of free conductor must be available. The conductor extension also ensures that undue stress will not be placed on the conductor during or after the splice connection. Where the opening of the outlet, switch, or junction box is limited in size to the point where the connection work must be done outside of the box, a minimum conductor length of 3 inches is required beyond the front edge of the box. Sections E3407.1 and E3407.3, conductor and terminal identification. Insulated grounding conductors of sizes 6 AWG or smaller shall be identified by a continuous white or gray outer finish or by 3 continuous white or gray stripes on other than green insulation along the entire length of the conductors. Equipment grounding conductors of sizes 6 AWG and smaller shall be identified by a continuous green color or continuous green color with 1 or more yellow stripes on the insulation or covering, except where bare. Insulation on the ungrounded conductors shall be a continuous color other than white, gray, and green. See the exception for insulated ungrounded conductors that are part of the cable or flexible cord assembly. In addition to the identification of conductors, electrical devices common to residential construction, such as receptacles that connect to both the ungrounded hot wire and grounded neutral conductors, typically require properly identified terminals. The identification requirement does not apply to panel boards or devices rated over 30 amps. Grounded conductors larger than 6 AWG may have the same markings as those 6 AWG and smaller, but the code also permits other colors of insulation, typically black, provided the electrician applies white or gray tape or marking around the conductor at the terminal ends at the time of installation. The similar allowance is provided for grounding conductors larger than 6 AWG. Section E 3602.2, service size and rating. The minimum load for ungrounded service conductors and service devices that serve 100% of the dwelling unit load shall be computed in accordance with Table E3602.2. Ungrounded service conductors and service devices that serve less than 100% of the dwelling unit shall be computed as required for feeders in accordance with Chapter 37. So Table E3602.2 sets forth a procedure for the calculation of the minimum service load. It is based on the square footage of the dwelling unit, the number of small appliance branch circuits, and the rating of any fastened in place, permanently connected, or dedicated circuit supplied appliances, such as ranges, ovens, clothes dryers, and water heaters. A demand factor is applied to the calculated sum, to which is added a load for the air conditioning and or heating equipment. So ungrounded service conductors, which are the hot wires, must have an ampacity of no less than the load to be served. The minimum rating of the ungrounded service conductors for a single-family dwelling is 100 amps, with an allowance of 60 amps for other installations. Section E3604.1. Open conductors and multi-conductor cables without an overall outer jacket shall have a clearance of not less than 3 feet from the sides of doors, porches, decks, stairs, ladders, fire escapes, and balconies, and from the sides and bottom of windows that open. So the clearances for overhead service drops are limited to conductors and cables that are not installed in a raceway or provided with an approved outer jacket. The requirement reduces the potential for damage to the service conductors and limits the risk of accidental contact. The clearance requirement from openable windows applies only to the sides and below the window opening. Service conductors and drip loops located just above an opening are deemed to be out of reach. So the need for a minimum 3-foot separation is based on the potential proximity of people to the service conductors. It is expected that contact is possible from open windows, porches, stairs, decks, and similar occupiable areas. No clearance is required from non-openable windows. Section E 3604.2.1. Conductors shall have a vertical clearance of not less than 8 feet above the roof surface. The vertical clearance above the roof level should be maintained for a distance of not less than 3 feet in all directions from the edge of the roof. See the 5 exceptions allowing for reduced clearances. The general provisions mandate at least 8-foot clearance between the service drop, conductor, and a roof. This clearance must not only occur directly above the roof surface, but also extend horizontally at least 3 feet, except for the point where the service drop is attached to the side of the building. However, separation may be reduced to 3 feet where the roof slope is 412 or greater. It is anticipated that travel across such a steeply sloping roof will be minimal. It is possible that the clearance will need to be increased to more than 8 feet where a roof is expected to have pedestrian access. This could occur where there is a rooftop court or sun deck, or where the roof is also the upper deck of a parking garage. Section E 3604.2.2. Overhead service conductors shall have the following minimum clearances from final grade. For conductors supported on and cabled together with a grounded bare messenger wire, the minimum vertical distance shall be 10 feet at the electrical service entrance to the buildings, at the lowest point of the drip loop of the building electrical entrance, and above areas or sidewalks accessed by pedestrians only. 12 feet over residential property and driveways, and 18 feet over public streets, alleys, roads, and parking areas subject to truck traffic. So the minimum clearances for overhead service conductors are based on the expected height of the potential hazards. Where there's no anticipated vehicle traffic, at least 10 feet of vertical clearance is mandated. Where vehicles are present, higher clearances are necessary. Where the overhead service conductor is attached to a building, the minimum height above grade of 10 feet must be provided. If other conditions exist that require greater clearance by other provisions of the code, they shall be satisfied. Grounding methods, section E 3608.1. All electrodes specified in sections E 3608.1.1, metal underground water pipe, E 3608.1.2, concrete encased electrode, E 3608.1.3, ground rings, E 3608.1.4, rod and pipe electrodes, E 3608.1.5, plate electrodes, and E 3608.1.6, other listed electrodes that are present at each building or structure served shall be bonded together to form the grounding electrode system. Where none of those electrodes are present, one or more of the electrodes specified in sections E 3608.1.3, 1.4, 1.5, and 1.6 shall be installed and used. See the exception for concrete encased electrodes of existing buildings. So one method of providing a grounding electrode is to use the metal underground water pipe that is in direct contact with the earth for a minimum distance of 10 feet. Where this method is used, it is necessary to also provide a supplementary electrode, such as electrode of pipe, conduit or rod, a ground ring, or a plate electrode. One or more complying reinforcing bars can be used as a grounding electrode when encased in concrete. The bar must be at least ½ inch in diameter, be at least 20 feet in length, and be located within and near the bottom of the concrete foundation or footing. Section R, IRC E 3608.3. Where more than one rod, pipe, or plate electrode is used, each electrode of one grounding system shall be not less than 6 feet from any other electrode of another grounding system. 2 or more grounding electrodes that are effectively bonded together shall be considered as a single grounding electrode system. Electrodes of rods or pipes can be utilized in a grounding electrode system. The minimum length of such made electrodes shall be 8 feet, embedded below the permanent moisture level if possible. Pipes or conduit must be a minimum of 3/4 inch diameter and trade size, while rod type grounding electrodes of stainless steel and copper or zinc coated steel are to be at least 5/8 inch diameter. A plate electrode can be considered a grounding electrode, provided it exposes at least 2 square feet of surface to the exterior soil and is installed a minimum of 30 inches below the ground. So at least 8 feet of the electrode must be in contact with the soil. The electrode should be driven vertically unless soil conditions are prohibitive. In such cases, the electrode can be driven at an angle of up to 45 degrees or placed in a minimum 30-inch deep trench. Straight vertically down, 45-degree angle, in a 30-inch deep trench. Section E 3702.14. The requirements for circuits having 2 or more outlets or receptacles, other than the receptacle circuits of Section E 3703.2, kitchen and dining area receptacles, E 3703.3, laundry circuit, and E 3703.4, bathroom circuits, are summarized in Table E 3702.14. Branch circuits in dwelling units shall supply only loads within that dwelling unit or loads associated only with that dwelling unit. Branch circuits installed for the purpose of lighting, central alarm, signal, communications, or other purposes for public or common areas of two-family dwellings shall not be supplied from equipment that supplies an individual dwelling unit. Whereas a 20 amp rated receptacle is not permitted to be installed on a 15 amp rated circuit, it is acceptable for a 15 amp rated receptacle to be located on a 20 amp rated circuit. However, Section E4002.1.1 requires that a single receptacle on an individual branch be rated equal to the rating of the branch circuit. A two-family dwelling may have areas that are common to both residences, such as landscape lighting and exterior accent lighting. Under such conditions, the power for the common area loads must be supplied from a separate service and panel board. Section E3703, required branch circuits. Central heating equipment, other than fixed electric space heating, shall be supplied by an individual branch circuit. A minimum of 2 20 amp rated branch circuits shall be provided to serve all receptacle outlets located in the kitchen, pantry, breakfast area, dining area, or similar area of a dwelling. A minimum of 1 20 amp rated branch circuit shall be provided for receptacles located in the laundry area and shall serve only receptacle outlets located in the laundry area. A minimum of 1 20 amp branch circuit shall be provided to supply the bathroom receptacle outlets. Not less than one 120 volt 20 amp branch circuit shall be installed to supply receptacle outlets in attached garages and in detached garages with electric power. So in addition to general lighting and convenience outlet circuits, a number of specific areas of a dwelling unit must be provided with their own dedicated branch circuits. The receptacles located at the kitchen countertop must be served by a minimum of two 20-amp branch circuits. One or both of the circuits may also be used to satisfy the requirements of the other outlets located in the kitchen and dining areas. Circuit identification, section E 3706.2. All circuits and circuit modifications shall be legibly identified as to their clear, evident, and specific purpose or use. The identification shall include an approved degree of detail that allows such circuit to be distinguished from all others. Spare positions that contain unused overcurrent devices or switches shall be described accordingly. The identification shall be included in a circuit directory located on the face, inside of, or in an approved location adjacent to the panel door. Circuits shall not be described in a manner that depends on transient conditions of occupancy. The importance of adequately identifying various circuits cannot be overstated. The code mandates that all circuits be noted in a legible fashion, indicating their purpose in a clear, evident, and specific manner. It is also important to adequately differentiate each circuit from all the others. The language of the code requires some degree of interpretation by the building official, as the provision is primarily performance in nature. However, it is obvious that generic terminology such as lighting or kitchen is not acceptable. Something that we should also touch on again, circuits shall not be described in a manner that depends on transient conditions of occupancy. Basically what that means is you can't say this circuit goes to Susie's bedroom. This circuit goes to mom and dad's room. Those are transient in nature because those may not be the same names if someone else moves in. Should be bedroom 1, bedroom 2, bedroom 3, bathroom 1, hall bath, master bath, things of that nature. All right, we are to the quiz. So hopefully you have your code book open and ready in chapters 34, 35, 36, and 37. I will read the question. Excuse me. I will read the question. You are to pause the video at that point and then look up the answer, come back to the video, and verify your answers. With that in mind, let's get started. Number 1, energized parts operating at a minimum of how many volts shall be guarded against accidental contact by people through the use of approved enclosures? Is that minimum 50 volts, 60 volts, 90 volts, or 110 volts? Our answer is A. Energized parts operating at a minimum of 50 volts shall be guarded against accidental contact. Find that in section E 3404.9. Number 2. An electrical panel board requiring access while energized shall be provided with a working space a minimum of how many inches in depth measured in the direction of access? How deep does that working space have to be? 30 inches, 36 inches, 42 inches, or 48 inches? Our answer is B, 36 inches. Find that section E 3405.2. Number 3. Workspace in front of an electrical panel board shall be a minimum of how many inches in width, but no less than the width of the panel board? Is that 30 inches, 36 inches, 42 inches, or 48 inches? Our answer is A, 30 inches. Minimum of 30 inches in width. Section E 3405.2. Number 4, the dedicated indoor space above an electrical panel board shall be a minimum of how many feet high or to the structural ceiling, whichever is lower. Dedicated indoor space above an electrical panel shall be a minimum of how high or to the structural ceiling, whichever is lower. That's at 4 feet, 5 feet, 6 feet, or 6.5 feet. And our answer is C, 6 feet high or to the structural ceiling, whichever is lower. I'm going to find that in section E, 3405.3. Number 5, the minimum size of electrical conductors for feeders and branch circuits, when of copper, shall be what AWG? Number 16, number 14, number 12, or number 10? It's the minimum size of electrical conductors for feeders and branch circuits. Our answer is B, number 14. Must be at least number 14. Find that section E, 3406.3. Number 6, where electrical conductors are to be spliced, terminator connected to fixtures or devices, a minimum length of how many inches of free conductor shall be provided at each outlet, junction, or switch point? 4 inches, 6 inches, 8 inches, or 12 inches? Our answer is B, 6 inches. Minimum length of 6 inches of free conductor shall be provided at each outlet, junction, or switch point. Find that in section E, 3406.11.3. Number 7, insulated grounded conductors of sizes 6 AWG and smaller may be identified by all but which of the following methods? Continuous white outer finish, continuous gray outer finish, continuous black outer finish, or 3 continuous white stripes on other than green insulation. Talking the grounded conductors, so the neutral. Answer is C, continuous black outer finish. Cannot have that. You can have any of these other 3, but not the continuous black outer finish. Find that in section E, 3407.1. Number 8, equipment grounding conductors of sizes 6 AWG and smaller may be identified by all but which of the following methods? Which method cannot identify an equipment grounding conductor that's size 6 or smaller? Continuous white color, continuous green color, bare, continuous green color with 1 or more yellow stripes. Our answer is A, cannot be a continuous white color because that's our grounded conductor color. Find that in section E, 3407.2. Number 9, in general, which of the following continuous colors is permitted for the insulation on ungrounded conductors? Which of the following continuous colors is permitted for the insulation on ungrounded conductors, your hot conductors? Is it gray, white, green, or red? Which of those can you put on the ungrounded conductors? Our answer is D, red. Find that in section E, 3407.3. Number 10, where it is impractical to locate the service head or gooseneck above the point of attachment of the service drop or overhead service conductors to the building, the service head or gooseneck shall be located a maximum of how many inches from the point of attachment? Is it 12 inches, 18 inches, 24 inches, or 36 inches? Our answer is C, 24 inches from the point of attachment. Find that in section E, 3605.9.3, the exception. Number 11. An open service conductor without an overall outer jacket shall have a minimum clearance of how many feet from the sides of the doors, porches, and openable windows? Is it 3 feet, 4 feet, 6 feet, or 8 feet? Our answer is A. Minimum clearance of 3 feet from the sides of doors, porches, and openable windows. Find that section E3604.1. Number 12. An overhead service conductor shall have a minimum clearance above a 312 roof of how high? 3 feet, 6 feet, 7 feet, or 8 feet? Our answer is D, 8 feet, section 3604.2.1. You can go lower if it's a 412 pitch or steeper. Number 13. Overhead service conductors shall have a minimum clearance of how many feet over residential property and driveways? Is it 8 feet, 10 feet, 12 feet, or 15 feet? Our answer is C, 12 feet over residential property and driveways. Find that in section E3604.2.2, number 2. Number 14. In all cases, the point of attachment of service drop conductors to a building shall be a minimum of how many feet above finished grade? In all cases. What's the lowest it can be? 8 feet, 10 feet, 12 feet, or 14 feet? Our answer is B, 10 feet. Find that in section E3604.3. Number 15. A metal underground water pipe used as part of the grounding electrode system shall be in direct contact with the earth for a minimum of how far? Is it 8 feet, 10 feet, 15 feet, or 20 feet? Our answer is B, minimum of 10 feet. Find that in section E3608.1.1. Number 16. Where more than one rod, pipe, or plate electrode is used in one grounding electrode system, each electrode shall be located a minimum of how many feet from other electrodes of another grounding system? Read that again. Where more than one rod, pipe, or plate electrode is used in one grounding electrode system, each electrode shall be located a minimum of how far from any other electrode of another grounding system? Is it 5 feet, 6 feet, 10 feet, or 20 feet? Our answer is B, 6 feet. Minimum 6 feet apart from a different grounding system. Find that section E3608.3. Number 17. Where a grounding electrode is made of stainless steel rod, the rod shall be a minimum of how much in diameter, unless listed, and a minimum of how long in length? Half-inch in diameter, 8 feet long. Half-inch diameter, 10 feet long. 5/8 inch diameter, 8 feet long. Or 5/8 inch diameter, 10 feet long? Our answer is C, 5/8 inch diameter, 8 feet long for a stainless steel rod. Find that in section E3608.1.4, number 2. Number 18. Where external to a building or equipment enclosure, an aluminum or copper-clad aluminum grounding electrode conductor shall be installed a minimum of how many inches from the earth? Where external to a building or equipment enclosure, an aluminum or copper-clad aluminum grounding electrode conductor shall be installed a minimum of how many inches from the earth? 6 inches, 12 inches, 18 inches, or 30 inches? The answer is going to be C, 18 inches. Find that in section E3610.2, number 3. Number 19. The rating of any one cord and plug connected utilization equipment not fastened in place shall be a maximum of what percent of the branch circuit ampere rating? Again, the rating of any one cord and plug connected utilization equipment not fastened in place shall be a maximum of how much of the branch circuit ampere rating? Is it 80%, 100%, 110%, or 125%? Our answer is A, maximum of 80% of the branch circuit ampere rating. We're going to find that in E3702.3. Number 20. A minimum of what branch circuits shall be provided to serve receptacles located in the kitchen, pantry, breakfast area, and dining area? 115 amp rated, 120 amp rated, 215 amp rated, or 220 amp rated? Our answer is D, 220 amp rated branch circuits to serve those loads. Sections E3703.2 and E3901.3. Number 21. A minimum of what branch circuits shall be provided for receptacles located in the laundry room, and a minimum of what branch circuits shall be provided to supply the bathroom receptacle outlets? Is it 115 and 115 amp rated circuits, 120 amp and 120 amp rated circuits, 115 amp, 215 amp rated circuits, or 120 amp and 220 amp rated circuits? Again, we're talking about the branch circuits for the laundry room and minimum branch circuits to the bathroom outlets. The answer is B. 120 amp rated branch circuit shall be provided for receptacles located in the laundry room, and 120 amp rated circuit shall be provided to supply the bathroom receptacle outlets. Sections E3703.3 and E3703.4. Number 22. In the calculation of electrical feeder loads, an electric clothes dryer shall be considered how many VA for each dryer circuit, or the nameplate rating load of the dryer, whichever is greater. Is it 4,000 VA, 5,000 VA, 5,500 VA, or 6,000 VA? Our answer is B, 5,000 volt amps for each dryer circuit, or the nameplate rating load of the dryer, whichever is greater. Find that in table E3704.2 parentheses 1. Number 23. When sizing feeder conductors, a minimum unit load of how many volt amps shall constitute the minimum lighting and convenience receptacle load for each square foot of floor area? Is it 2 volt amps, 3 volt amps, 5 volt amps, or 6 volt amps? Our answer is B, 3 volt amps. Find that in section E3704.4. Number 24. What is the maximum overcurrent protection device rating permitted for number 12 copper conductors? Is it 15 amps, 20 amps, 25 amps, or 30 amps? Answer is B, 20 amps. Find that in table E3705.5.3. Number 25. Which one of the following ratings is not a standard ampere rating for fuses and inverse time circuit breakers? Which one is not a standard ampere rating for fuses and inverse time circuit breakers? Is it 25 amps, 50 amps, 75 amps, or 100 amps? Our answer is C, 75 amps. You find that in section E3705.6 and table E3705.6. Number 26. Where metallic plugs or plates are used with non-metallic electrical enclosures to close unused openings, they shall be recessed a minimum of how much of an inch from the outer surface of the enclosure? It's an eighth of an inch, quarter of an inch, 3/8 of an inch, or half an inch from the outer surface of the enclosure. Our answer is B, 1/4 of an inch. Find that in section E3404.6. Number 27. Electrical panel boards and overcurrent protection devices shall not be located where? Clothes closets, sleeping rooms, garages, or storage rooms. Answer is A, clothes closets. Panel boards cannot go into clothes closets. Find that in section E3405.5. Number 28. Where the opening to an outlet, junction, or switch point is less than 8 inches in any dimension, each electrical conductor shall be long enough to extend a minimum of how many inches outside of such opening? Where the opening to an outlet, junction, or switch point is less than 8 inches in any dimension, each electrical conductor shall be long enough to extend a minimum of how many inches outside the opening? 2, 3, 4, or 6 inches. Our answer is B, a minimum of 3 inches outside the opening. Section E3406.11.3. Number 29. Electrical service disconnecting means shall not be installed in where? Laundry storage closets, laundry rooms, sleeping rooms, or bathrooms. Electrical service disconnecting means shall not be installed in which of those locations? Our answer is D, bathrooms. You're going to find that in section E3601.6.2. Number 30. In order to be used as part of the grounding electrode system, interior metal water pipe shall be located a maximum of how many feet from the point of entrance to the building? Is it 3 feet, 5 feet, 6 feet, or 10 feet? Our answer is B, a minimum of 5 feet from the point of entrance to the building. Find that in E3608.1.1.1. Number 31. Electrical conductors located above a roof shall be installed with a minimum vertical working clearance of how many feet where the roof has a slope of 8/12? Electrical conductors located above a roof shall be installed with a minimum vertical clearance of how many feet where the roof has a slope of 8/12? Our answer is A, minimum of 3 feet above that roof, because with a slope of 8/12, that's steep enough that it's not going to be walked on very often. I'm going to find that in section E3604.2.1, exception number 2. Number 32. Service entrance cables shall be supported by straps or other approved means within how many inches of every electrical service head and at maximum intervals of how many inches? Is that 8 and 30, 8 and 36, 12 and 30, or 12 and 36? Our answer is C. So service entrance cables shall be supported by straps or other approved means within 12 inches of every electrical service head and a maximum intervals of 30 inches. Find that in section E3605.7. Number 33. Plate electrode installed as part of a grounding electrode system shall be located a minimum of how many inches below the surface of the earth? Plate electrode. Is it 12 inches, 18 inches, 24 inches, or 30 inches? Answer is D, a minimum of 30 inches below the earth, below the surface. Find that in section E 3608.1.5. Number 34. Where an electrical branch circuit has multiple outlets, what is the minimum required size of circuit conductors for a circuit rated at 30 amps? Where an electrical branch circuit has multiple outlets, what is the minimum required size of circuit conductors for a circuit rated at 30 amps? Is that 14, 12, 10, or 8? Our answer is C, number 10. Find that in table E3702.14. All right, number 35, our last question. An overcurrent protection device shall be installed so that the center of the grip of the operating handle of the switch or circuit breaker, when in its highest position, is located a maximum of how high above the floor or working platform? Is it 5 feet 0 inches, 6 feet 4 inches, 6 feet 7 inches, or 7 feet 0 inches? Our answer is C, 6 feet 7 inches. Find that in section E 3705.7, number 6. That concludes our study session number 17. I want to thank you for going through this with me. Hope you got all of those answers correct. If not, just keep working through those until you're comfortable finding all the answers. Until next time, I'm Dave Kilgore. Thank you.